Okay, this lesson covers some material from Unit 1415. This is Box D. We're looking at X and Y intercepts. And at the end of this lesson, we want to be able to find the X and Y intercepts of a line, both from a graph and algebraically, and also we want to be able to graph a line using these intercepts. So the first thing we should get out of the way here is what exactly do we mean by the X-intercept and the Y-intercept? Well, we've already encountered the Y-intercept when we looked at the equation of a line. We know that the Y-intercept is the y value where the graph crosses the y-axis. So if we've got a graph of our line here, we look where this thing crosses the y-axis, and that's right there. So that's going to tell us that our y-intercept is 2. Let's just say y-int equals 2, because the value right there is 2. Now we could label the coordinates of this point. This has got an x of 0 and a y of 2. Okay? So this also gives us a point here, 0, 2. And what's important about this point is that anytime you're looking at a point that is on your y-axis, okay, your y-intercept is always going to be on this y-axis. Your x-coordinate is always going to be 0, okay, because it's where it crosses that y-axis. Similarly, our x-intercept is the x value where the graph crosses the x value, the x-axis. So again, if we look at this graph here, we find where our line crosses the x-axis. That's right there. So our x-intercept here is -4. Okay? But this also can be the ordered pair, or the coordinates of a point. We could label this -4, 0. Okay, our x is -4 and our y is 0. So with any point that is on our x-axis, the y-coordinate is always going to be 0. So if our point is on the y-axis, x is always 0. If our point is on the x-axis, y is always 0. So we're going to use those two pieces of information and the equation to find our intercepts algebraically. So we want to be able to find the x-intercept and y-intercept from an equation. So they give us an equation here. 3x minus 6y minus 12 equals 0. Okay, this is an equation in standard form. To find the x-intercept, we set y equal to 0 because we know if we're looking for the x-intercept, it's going to be on that x-axis, and the y-coordinate is going to have to be 0. So we can set y equal to 0, and we can solve for x. So let's just sub in y equals 0 into our equation here. We get 3x minus 6 times 0 minus 12 equals 0. This term, of course, is going to go away because 6 times 0 is just 0. And now we want to solve this thing for x. So I can add 12 to this side, add 12 to this side, and get 3x equals 12. So what is my value of x going to be here if I've got 3x equals 12? That's right. It's going to be 4, right? I divide both sides by 3 here, and I get x equals 4. So there is my x-intercept. X equals 4. I can do the similar sort of thing to find my y-intercept. If it's our y-intercept, we know it's going to be on our y-axis, so we can set x equal to 0 and then solve for y. So I'll do that in blue over here. We're going to set x equal to 0, so 3 times 0 minus 6y minus 12 equals 0. Again, 3 times 0 is just going to be gone because 3 times 0 is just 0. Again, I can add 12 to this side, add 12 to this side to move that 12 over to the other side, and I'll have negative 6y equals 12. What's my value of y going to be here if negative 6y equals 12? Chris? Negative 2. So there is my y-intercept. Okay. Y equals negative 2. Okay. Now I can use this, my x-intercept and my y-intercept, to plot my line really quickly. If I know that my y-intercept is negative 2, I just go to negative 2 and put a dot on my y-axis. If I know my x-intercept is 4, I just go to my x-intercept and I put a dot on 4. Okay? If I connect those 2 points with a straight line, that is going to be the graph of my line. I didn't quite connect them there, but if I do that and I do that, there we go. There's the graph of the line. So I subbed in x equals 0, subbed in x equals 0, solve for y, subbed in y equals 0, solve for x, plotted those two intercepts, and then connected them with a line, and that gave me my graph. Okay. So let's do one more example here. We'll do this one together. So again, they want us to find the x and the y-intercepts and graph the equation. Which intercept do you want to find first? Andrew, which one? You want to find the x or the y? So we're going to find the x-intercept. Okay. If we're finding the x-intercept, it's y that we want to set to 0. So I'll just say right here, y equals 0. Okay. So I'm going to plug in y equals 0, 4x minus 2 times 0 plus 16 equals 0. And of course, that term goes away. I got 4x plus 16 equals 0. Okay, what am I going to do from here to solve? Chris? Yeah, I can subtract 16 here, subtract 16 here. I could probably just do that in my head, but I get 4x equals negative 16. And then what is x going to be here, Chris? Close. Negative 4, yeah. We're dividing both sides by 4. We got a negative divided by a positive. So our x-intercept is going to be negative 4. So I might plot that point on the graph right away. I go on my x-axis, I find negative 4. And there's my x-intercept. Okay. Now, I guess I'll come down here a little bit, and we will do our y-intercept here. So how am I going to find my y-intercept? What do I have to set to 0 to solve for my y-intercept? I have to set x equal to 0. So in my equation, I am going to put x equal to 0. 4 times 0 minus 2y plus 16 equals 0. Just going to double check that I got that equation right. Yep. And then, of course, the 4 times 0 just goes away. So I've got 2y plus 16 equals 0. And I want to solve for y here. So I'm going to try it. What am I going to do? Okay. And I'll get negative 2y is negative 16. And what do I do from here? Right. Divide both sides by negative 2. And that's going to get me y equals positive 8. Okay. So I can plot y equals positive 8 as my other intercept way up here like this. Connect the two of them with a straight line, and that'll be my graph. Oh, that's not exactly a... There we go. There, that's better. There we go. Connecting with a straight line, we got our graph. And we're done with x and y intercepts.